Imagine trying to clean up the planet and accidentally making the skies go quiet. Sounds like a sci-fi movie, right? But this actually happened. In 2020, new rules to cut pollution from cargo ships set off a chain reaction so unexpected, even scientists were shocked. Ocean lightning strikes dropped by half. I'm host El Rafa from Crucial Post. Get ready. This isn't just about ships or storms. It's about how we're unknowingly changing the way nature works. Let's talk about the dirty secret of global trade. For over a century, the backbone of global trade, cargo ships, ran on a fuel so filthy it's almost hard to believe. Bunker fuel, a tar-like sludge left over from oil refining, was cheap, abundant, and toxic. When burned, it spewed sulfur dioxide, SO2, into the atmosphere, a pollutant linked to acid rain, lung cancer, and over 250,000 premature deaths annually. But sulfur had a dark superpower. It masked global warming by reflecting sunlight back into space. Think of it as Earth's accidental sunscreen. In 2016, the International Maritime Organization, IMO, dropped a bombshell. By 2020, sulfur in ship fuels would be slashed from 3.5% to 0.5%. The goal? Save lives. And it worked. Air quality improved overnight near ports and coastlines. But beneath the surface, a hidden experiment was unfolding. Ships weren't just polluting the air, they were engineering the weather. So how ship pollution fueled storms? To understand how cleaning up ship fuels silenced the skies, we need to talk about aerosols, the tiny particles so small they're invisible to the naked eye. In every liter of air, there are tens of thousands of these microscopic clusters. In polluted cities, that number skyrockets to millions. But what do these tiny particles have to do with clouds, storms, and lightning? Everything. Aerosols are the unsung architects of clouds. They act as seeds or nuclei for water vapor to condense into droplets. The more aerosols, the more droplets, and the brighter and taller the clouds. In shallow, puffy cumulus clouds, extra aerosols make clouds whiter and more reflective, scattering sunlight and cooling the earth. But in towering storm clouds, the story gets more chaotic. In storm clouds, those extra droplets freeze into ice crystals. When water freezes, it releases latent heat, fueling the storm's intensity. Ice crystals also splinter, creating more particles that collide and generate electric charge. This chaotic dance of freezing, heating, and colliding is what sparks lightning. But here's the catch: the process is so complex it's nearly impossible to predict how aerosols will shape a storm. We can't recreate thunderstorms in a lab, but nature has given us an accidental experiment: the world's busiest shipping lanes. Ships emit massive amounts of aerosols, especially sulfur particles. These emissions act like a giant cloud seeding machine, supercharging storm clouds and electrifying the skies. But when we cleaned up ship fuels, we removed those aerosols, and the lightning vanished. Nowhere was this experiment more dramatic than at the port of Singapore, the busiest shipping hub in the world. With engines often 3 stories tall, ships here burned viscous fuel oil, emitting copious amounts of soot and sulfur particles. Fast forward to 2023. Scientists noticed something odd. Lightning strikes over 2 of the world's busiest shipping corridors, the Indian Ocean and South China Sea, had plummeted by 50%. At first, it seemed impossible. How could cleaning up ship exhaust affect lightning? The answer lies in a process as old as Earth itself: cloud formation. Remove the sulfur, and the clouds lose their spark. No particles, no collisions, no electric drama. It was like unplugging nature's Tesla coil. But this wasn't just a maritime quirk. A 2021 study found coal pollution in China had suppressed thunderstorms for decades. When China cleaned its air in the 2010s, lightning surged by 30%. Our atmosphere, it turns out, is a Rube Goldberg machine, and pollution is one of its most unpredictable gears. Let's talk about the unintended consequences of geoengineering, and here's where it gets existential. For years, scientists have debated solar geoengineering, a controversial plan to spray sulfates into the stratosphere to cool Earth. But the ship fuel saga reveals we've already been geoengineering by accident. And the results? Unpredictable, uneven, and full of hidden risks. A 2023 report warned that deliberate aerosol injection could collapse monsoons, starve crops, or trigger droughts. Even the COVID-19 lockdowns, which briefly cleared skies, altered weather patterns. Less pollution over India, for example, led to hotter days and freak hailstorms. As climate experts point out, we're playing Jenga with the atmosphere. Remove one block and the whole tower shudders. Can we predict the unpredictable? To navigate this brave new world, we need more than good intentions. We need precision, advanced climate models, real-time atmospheric monitoring, and global cooperation. Projects like the European Union's Destination Earth aim to create a digital twin of our planet, a virtual lab to simulate policy impacts before they're enacted. But until then, every decision is a gamble. From space, Earth looks serene, but beneath that blue veneer, it's a seething, interconnected web, a web we're tugging at with every law, innovation, and tank of fuel. Progress isn't a straight line, it's a maze. Cleaning our oceans silenced the skies, but it also taught us humility. As we march toward a greener future, let's listen to the lightning. Let's study the storms, and let's remember, in the Anthropocene, even the clouds bear our fingerprints. If this story electrified your curiosity, hit like, subscribe to Crucial Post, and join the conversation below. Stay curious, stay bold, and never stop questioning the sky. See you next time.